Imagine you're at a concert, and the conductor is leading a symphony. Each instrument plays a crucial role in creating beautiful music. In the world of electricity, resistance and IV, current voltage characteristics, are like the notes and tempo of this symphony. Determining how electric current flows through a conductor. Let's embark on a journey to understand these concepts and their significance in the realm of electrical circuits. Resistance is the property of a material that opposes the flow of electric current. It's measured in ohms, ohms. Think of resistance as the friction you feel when sliding your hand across a surface. Some surfaces are smooth and easy to slide over, low resistance, while others are rough and hard to move across, high resistance. Factors affecting resistance include 1. Material. Different materials offer different levels of resistance. Conductors like copper have low resistance, allowing current to flow easily, while insulators like rubber have high resistance, blocking current flow. 2. Length. The longer the conductor, the higher the resistance. 3. Cross-sectional area. The thicker the conductor, the lower the resistance. 4. Temperature. As temperature increases, resistance usually increases for conductors. IV characteristics. The graphical representation of electrical behavior. IV characteristics describe how the current, I, through a component varies with the voltage, V, across it. This relationship can be visualized using an IV graph, where the x-axis represents voltage and the y-axis represents current. Different components have distinct IV characteristics. Ohmic and non-ohmic conductors. 1. Ohmic conductors. These are materials that follow Ohm's law, where the current through the conductor is directly proportional to the voltage across it. The IV graph for an ohmic conductor is a straight line passing through the origin, indicating a constant resistance. For example, a resistor or wire. 2. Non-ohmic conductors. These materials do not follow Ohm's law, and their IV characteristics are non-linear. The resistance of non-ohmic conductors changes with voltage or current, for example, a diode, which is a semiconductor device that allows current to flow in one direction only. Its IV graph shows very little current until a certain threshold voltage is reached, beyond which current increases rapidly. In a filament lamp, the resistance increases with temperature, causing the IV graph to curve upwards as the voltage increases. Let's conduct a thought experiment to investigate the IV characteristics of different components using a simple circuit with a power supply, an ammeter, a voltmeter, and the component under test. Experiment 1. Resistor, ohmic conductor. 1. Setup. Connect a resistor to the circuit. 2. Measurement. Vary the voltage using the power supply and measure the corresponding current using the ammeter. 3. Observation. Plot the voltage against the current. The result is a straight line through the origin, indicating a constant resistance. Experiment. 2. Diode, non-ohmic conductor. 1. Setup. Connect a diode to the circuit. 2. Measurement. Vary the voltage and measure the current. 3. Observation. Plot the voltage against the current. The result shows very little current until the threshold voltage is reached, after which the current increases rapidly. Experiment 3. Filament lamp, non-ohmic conductor. 1. Setup. Connect a filament lamp to the circuit. 2. Measurement. Vary the voltage and measure the current. 3. Observation. Plot the voltage against the current. The result is a curve that indicates increasing resistance with higher voltage. Understanding the IV characteristics of components is crucial in designing and troubleshooting electrical circuits. Here are a few applications. 1. Electronic devices. Knowing the IV characteristics helps in selecting the right components to ensure proper functionality and prevent damage. 2. Power supply design. Engineers use IV characteristics to design power supplies that provide stable voltage and current to electronic devices. 3. Circuit protection. Understanding how different components behave under various voltages helps in designing circuits with appropriate protection mechanisms like fuses and surge protectors. The study of resistance and IV characteristics is like understanding the notes and rhythms of an electrical symphony. Resistance plays a vital role in controlling the flow of current, while IV characteristics reveal the unique behavior of different components under varying voltages. Together, they provide a comprehensive understanding of how electrical circuits operate, enabling us to harness the power of electricity in our daily lives. As you explore the world of electrical circuits, remember the intricate dance of electrons and the symphony of resistance and current. It's a journey that transforms the invisible forces of electricity into the tangible wonders that light up our lives and power our technology.